Okay, we're going to do our part 2 of our graphic screen lessons. This may take a while and it gets kind of detailed, but it's one thing we need to do. So I'm going to back over here and refresh some of these screens. Okay, this is our program. Okay, we'll start with just looking at start with a little overview of the program. We're going to have our common included like we do. This looks pretty much like our other programs, so I'm trying to stay consistent with that stuff. So we use our common interface, and that's all the same. We'll get down here, and here's where our program really starts out. Okay, the beginning of screen address is 2000. Remember in part 1 we just talked about when you bring in the screens, they come in at 2000 because we have little programs, so we keep them down low, and that's what we're going to do here is leave it at 2000. This arg at E00, this is what we're going to change. Okay, this is all the defaults for this program. There's a basic program that will use some pokes to change this here so we can test 4 different screen types, but this is the default. Default is going to be 256 by 192.16, which is the common one I use most of the time. And this is the bit pattern, or it really is a 1A. The length of it is 6,000 hex bytes. Screen bytes, number of bytes across the screen is 128. Okay, that makes 256 pixels. And screen beginning, okay, which is the beginning up here. And the end of the screen is 8,000. So that'd be 2,000 plus the 6,000, 8,000. Anyway, these are temporary, and they're the defaults. Okay, we'll get into what the basic program's going to do. So what we're going to do, the very first thing it does is takes our beginning, add the length, and store it in the end. So it's going to come up the same, but that's just for when we have different information coming in from basic. All right, screen definition, we're going to look at that here very soon. And that up here is this definition is this 1A. Okay, we're going to see what that looks like. We're going to store it in some place called IMDef. Okay, well, we're going to cut that off right now, and we're going to go quick down here and look at what IMDef means. Okay, for the graphic screen, I got it down here, and these are asterisks, so these are notes. Okay. This is what a graphic screen parameters look like. I know it's hieroglyphics now, but we're going to look at it. All right, so this is what it defaults is this 4C. We'll look and see what that comes up with. And then this 80, here's our 1A, that's our default. This is the border color 00. Now if we put in some other number, that's red palette register 0, so that's for black. So anyway, I got this 0 in there. These next 2 bytes, nothing we use here. And here's that C00. This is the address that the graphic screen is located at. Okay, so that's just remarks just to look at. In this little section right here, what's called IM graph. Okay, well, I'm going to jump over here to Extended Basic Unraveled, and you should have downloaded and looked at this from Color Computer Archives. And you'll see in here they got a thing called IM graph. I use the same names because what they did, I looked at what they did, and it's pretty simple. Look at this line here, okay? If you take this MMUEN plus MC3 plus MC2, it compiles over here. You can see it's 4C. Well, what is all that stuff? Okay, well, let's run way back up here somewhere. If we can get back up here, oh, we got to go way up, and we'll take a look. And I think we're just about there. Okay. All this information in here, and you can see there's just a ton, and you can look at this. Okay, this is all the different bits you can set. All these bits you can set in this view. Okay, there's a lot of them. Palette, except okay, and that's what all this stuff up here is. Okay, so to net it out, I've went through it, and I said I don't think I understand the hardware good enough myself. You may want to learn that. but I said, I'm going to believe that they know what they were doing, and I'm going to stick with what they put in there, which was, I think we should be back here. They put it in there, these information in here, and come up to 4C. So I said, okay, I'll use 4C forever, and it's worked. This other hex 80, okay, that's a harder bit, and that says we're going into graphics mode. If it's not in there, it's not graphics mode. So I'll go with that. I'll deal with that. The next 00 in there is the border color. Well, I can change that anytime I want. And it's defaults to 0, and my palette is 0, so that's okay, but I can change that anytime I want. The next 2 bytes, they left them at 0, and I looked, and there's nothing that I probably ever want to use. I'm sorry, I was off. This first 00 is our definition. That's where our 1A would go. It says what type of scrim we want. The next byte in is the border color. The next 2 bytes are unused. And in here, see this C000, that's where the graphic screen starts. It's, that's everything we need. That's some 5 or 6 registers, so we'll just go with that. So I'll use the same thing. I'll even use the same name. So what is all the different screens? Okay, one thing while we're here, you look up here. I don't know what restable means, but anyway, it's a hex 15, and what this is H screen 1, H screen 2, H screen 3, and H screen 4. That's the 4 screens that BASIC will give you, okay? Right there. And what they do, you go back up here, they'll go through all this code up here and verify that you typed in everything else, the mode, and compare all that, and they get it all done, and they'll load A off of which one of these 4 here ends up in A, and they store A and 2 off of X. X is pointing to this 4C down here, and the second byte in is where they store. They'll store either one of these 4 to give you H screen 1, 2, 3, or 4. So all we have to do to one of the 20 some odd screens are ours, we just have to store something in there. So go back over to our code, okay? And in ours, I call it the definition, and we'll just put on this default one, going to put 1A in there, which is 256 by 192. So that's all we have to do, is stick something in there and change the color if we want. If not, that's it, and that's all we need to do, and everything's good. You can just, by changing that, you can have one of the 20 some odd screens. Easy enough. How do we do that? Well, here's the code, which is called set mode. Okay, I'm going to jump back over here, and here's where they set video. Okay, you can look at it all you want, but they load A and they stored it FF90. They load something else up and they go this little loop here. Now, go back to our code. We load it up, store that in 90, and we do this little loop. It's the same code as theirs, it's just I did it over here. Very, very simple. So all we have to do is change this few things in here, branch to this routine, and we're in the graphics mode. So all in bits and stuff, I think you won't have to do a lot of research on them, but do all you want. I've researched them, and well, if I had hair, it would have turned gray, I know for sure. Likewise, you see here's one that says I am text. If you want to go back to a text screen, okay, let's jump back over here to the way they did it. Okay, I think I'm getting, okay, here's the text. I am text routine. They have 3 of them. One for 32 column, one for 40 column, one for 80 column. I used everything 80 columns, so I said I'll just copy out the same thing. Here's that 4C, and this first bit in here, remember, if it had the 80, it was graphics, but the 03 is for the text, and 15 is the rows and bytes per row, and etc. And where it's located is at D800. That's where the text screen is located. Okay, so what I did back here in our code, the text screen, I just copied it over and put it in there. Their screen, they default to that beautiful color green when you turn your machine on, even if you're in 80 character mode. That's what this node is here, this 12. I just changed it to 00, so it'd be a black background, a black border as opposed to the crazy green. Okay, It's the same thing, the same routine. Load up this address here, branch to this routine, and bang, you're back in 80 column mode. Very simple. You don't have to go to some doctorate school to learn all this stuff. Now, if you want to learn more about the hardware, be my guest. Not enough. I just know that these routines work very, very simple. Okay, let's go back up here to where we were. So we took our screen definition, which up here was, again, this default is 1A. We stored it in IM definition below. Now the rest of this stuff is kind of common, what we've been doing. Disable the CPU interrupts, save our stack, move our stack, high-speed poke, store palettes the way we've done in the past. The same exact routines. None of that's has changed. Okay, and I'm going to disable, I'm still calling it MMU interrupts for now. We're going to turn them off. We don't need them. And go to task 1. All we do is load up A with this 1 and store it in FF91, and bang. We are in task mode 1. Remember, all this stuff changed, so most of that basic stuff is gone. All right. Well, I load up that IM graph and jump to set mode. That's what we just looked at. Okay, we'll get it again. We load up IM graph, which is right here. We load that address up and we go to set mode. It runs through it, puts all these in the correct registers for you, and you're done. So when you do that, you're in graphics mode. Whatever you give it. In this example here, we're in 256, 192 by 16 colors. All right. Now I put this in here. The correct address of C00 was already in there, but I just put the formula in here to show you that it works in the code. And when you compile it, okay, if we down here and we move this over, when it compiles over here to C00. So if you ever need to change it, which you will, and someday you'll have it. All right, so we've done that. Oh, I'm sorry, yeah, and then we did our set mode and do a clear screen. Clear screen takes all the stuff that we had up at the beginning of the screen, which is 2000. We put our background color is black, so we put that in D for both pixels, and we store D and X++. We just do this loop till the end of screen. In this case here, it's 6,000 hex bytes long, so that will go through there until it gets to the end, and bang. We've got a clear screen now. We haven't had BASIC do anything for us yet. We're doing it all on our own now. Now we're going to actually do some code with that screen. Okay, we'll draw some lines for easy viewing. So I just picked an address 4000 because what we're using is 256 by 192 by 16, and that is again 6,000 hex bytes. So it's the beginning's at 2000. And then we got 4,000 and 6,000. So I just went down a third of the way down the screen. I said, well, just use address 4,000. And you'll see when we actually use the basic program and the other program why we did that. So here's we're address on the screen where we're going to display some lines, okay? We'll put that in, we're going to push X. We're going to branch to a routine called do lines, okay? Very, very nice name. Well, here's a do line, okay? Now, if you remember back, I'm going to refresh your memory from what we're going to do is we're going to use, here's our palette, our standard palette, and all these tests we're going to do, we're going to use either 16 or 4. We're not going to do any two colors. That's pretty simple. It's either on or off, on or off. So we're going to use these two examples. We'll be using our examples here, so we can use the same bytes in here and come up with different results. Okay, this one here, if you look at this 4-color, we got 0. The first pixel in there is going to be 0, 1. Or sorry. This is black, blue, gray, or green. Oops. Now, if you look at this in hex, that's 0, 1, and that's a B. Just looking at hex. Okay, so we got a 1B. Right? Now, if we put 1B up here, we'd end up with first pixel would use color palette 1, which down here would be blue. The B over here in the second pixel would be a B, which is going to be green down here. This is the second row, end up with the green down here. So we'd have blue and green. Here we'd have black, blue, green, gray, and green. Hopefully I probably am over confusing this, but so we're going to put 1B in both, in A and B's. And here again it says if we got a 16 color screen, you'll have blue, green, green. A 4 color screen, you'll have black, blue, gray, and green. And we're going to store 8 times. We're going to store it and bump it up. Okay, so we'll have 32 pixels. Well, it all depends on which mode we're doing. So we'll have like 32 pixels to make a sharp line on the screen. Well, it's very hard to see it. It's so small. So what we're going to do the same thing 4 times. So we'll draw 4 lines, one right below the line, so at least it's easier to see. We'll do that. Branch to end of job. Into jobs, we'll do our end key, which we learned in the last session. We're looking for Q. Here's our end key loop. Just to refresh your memory, looking for Q. We're gonna bang this register, okay, and we're gonna complement it. We're gonna look for Q. If it's found, we'll go to find Q, and we're gonna set the carry flag. This is different we did last time, but it's the same results, so you may want to look at this. We're going to set the carry flag. If it doesn't find it, it's going to clear the carry flag. So one way it'll be set if we find it. So we'll go back up here and branch if the carry is clear. Didn't find it, so we'll just keep moving until the carry flag is set. Once it's set, it means it found the queue. We'll bang this register again, go back to task 0. We'll put that IM text in there. We'll branch the set mode. We'll go back into text mode. We'll restore the stack, restore our palette, turn the interrupts back on, bang, go back to basic, and we're done. Okay, so that's what's this program. Not a lot of program in there. I mean, a lot of the stuff is the same. You could copy the programs that we did before. It's the same stuff. Trying to keep it the same. So we've looked at that, and we've looked at Unraveled Basic, which you should do. You can see exactly how they did it. Now comes the other part of this. These are their 5 registers that we were filling up. Okay, now let's get down here and let's look at all this stuff. And here, make your life easier. This is the table, and I'll put this out there in a zip file so you have this table. And this table here, I had this here in a bunch of notes. They're the ones I wanted to use, not all of them, but I had a lot of them that I experimented with a long time ago. And somewhere on the internet, I found somebody else had typed a lot of this stuff in. Okay, so it's kind of neat. So I took what they had, expanded it. I added some other things to it, like the hex addresses, and I cleaned it all up and put it together. Now, there's 20 some different screen modes you can get into. Okay, and down here, here's what H screen 1 is. Okay, it's 320 by 192, 4 colors, and takes 3 Charlie 00 worth of RAM. Okay, that's the number of bytes it uses. So it wouldn't take all 4 of the. In fact, it would only take 2. It'd be less than 4,000. So it only would take 2 blocks to do H screen 1. H screen 2, which we've been using in the past, is 320 by 192 by 16. Takes a whole bunch, 78. It will take the 4 blocks. Okay, so H screen 3, again, it's 640 by 192, 2 colors, so it doesn't take very much either. So it can do it in 2 blocks. And H screen 4 is a pretty big one, also 640, 192. Well, and it takes 78. Now, having said that, all these are all different. And the thing you need to know is if you can use either the hex notation or the binary notation to get what you need. Now, if you notice out here's a couple asterisks. These 2 particular, if you look at them, they're 8 Charlie A0. Take up a lot of memory. Okay, if we use 4 blocks, that's 2, 4, 6, 8. Well, this is 8 Charlie. This will take 5 blocks. Okay, remember, you could have 5 consecutive blocks, but we're only set up for 4. You can do it yourself, but you just be careful that you know that when you're going in this mode, you're going to have to use 5 blocks instead of 4, and you have to adjust your code accordingly. So that's what them 2 have a notation for. Other notations in here, if you look, some of these here have a dash in front of them. That's the 4 we're going to do in our test. Okay, this load, where this load here, A here is, if you want to do this manually, you can do a load A of either this binary or this hex notation, And if you store it in this thing here, you can do it manually, but you have to set all them other registers manually also. So that's just to let you know, that's how you would do it. So we're going to be testing 256 by 192 four colors. This is the standard one that I use most of the time, 256, 192, 16, and we'll test this one here, 320 by 200, and we'll also do H screen 4. We'll also test it. We'll do it manually. So that's all this thing is. This table here is what you need, and I suggest when you get all this stuff, you'll see how to change the basic program, and you can test all of these in different modes that you want to test. So that is kind of it. Let's bring up the basic program. Okay, and I've loaded and I'd actually run it so you can see on the screen what it's going to ask for. Either 1, 2, 3, or 4. There's the 4 of them I said we'd test. We'll test them 4. The other thing was to load our program in. The other one is to exit. Okay, so let's part of it and give you just an idea. And I'm not very good at basic, so I don't do a lot of tricky stuff. I kind of like to spell it all out. So in here, if you typed in a 1, you would get down here to line 170, and you're going to poke in 1 into the definition. All right, I'm going to go flip back and forth here so it makes you understand. That's this test right up here with its dashes. Here's our hex 11, and our RAM size is 3000, and it's 4 color. So then we'd put the hex 11 into the definition at E00. The screen length is 3000, so we need to break it down into 2 bytes. So we're going to put the 30 into 01, the 00, and 02, and then the bytes per line. So it's either going to be the number, it's 256 bytes across, or pixels across. It's 4 colors, so we're going to divide it by 4. Not because it's 4 colors, that's just we divide it by 4. And that will give us a calculation when we're drawing them lines so we can do it correctly. The next one down here is my standard one, would be 1A. The hex bytes would be 6000 and 256 across, but it's 16 colors, so we only get 2 pixels per byte, so we divide it by 2. Okay, and then get poked in, and then go back to our program, so we make sure we understand. It will be located right here. Okay, let's move this over. At E00, whatever we poked, a 1 would be a 1A or a 1, poke in there. The length, either the 3000 or 6000. The bytes across would go in there, and the rest of it gets calculated in this routine here. So it's going to poke them 3 items in, and the rest of it will work itself out. So back to, okay, let's do a test and see what we have. Okay, I'll do a 1 for 256 by 192. Bring up the magnifier so we can maybe see a little bit better. All right, there's a 4 color that has, excuse me, the black, blue, gray, and green. I hit Q to quit. We'll do a number 2, which is 256, 192, 16. Right. That has the blue, green, blue, green, blue, green. Quit, do number 3. And that one also is 16 color. It's a little bit higher resolution, but it's blue, green also. Quit, do number 4. And that is a 4 color one, which is the black, blue, gray, green. As you can see, when we go through them, get rid of the magnifier. As we go through them, they are different places on the screen. That's going to kind of the higher resolutions and lower resolutions. So I'll do 1, and you'll see where it shows up on the screen. Do a quit, do number 2. See where it shows up on the screen, it's a much higher resolution. Do a quit, do number 3. It's on a different place on the screen, but a different resolution. Quit, and 4. Okay, so using that address 4000, they'll show up different places on the screen. So that's what this exercise looks like. Do a 9 to get out of there.